Hey guys, welcome back to my shop. So about the Johnson Shipman, pulled the motor in the last video and I noticed there's a big run out on the shaft. Somehow it got bent, no idea how it happened. Probably it got dropped in repair somewhere. But I need to fix it, so let's see if I can save this motor and yeah, let's get to it. So I have the shaft here on the welding table because yes, I am gonna weld it and try to pull it straight. Maybe some of you think, oh no, what you gonna do? But it's a little bit scary maybe, but I'm confident that I can do that. Put a tiny little bead on there, and the bead will always shrink the material a little bit when it heats up. That will pull the shaft straight, and I can check where's the high point. Sorry for the noise on the steel feel blocks. Have an indicator on there and see how much it will move. That will be interesting to see. Start with a very tiny bead and then I can always go up from there. This is the position where I think the shaft is bent. So it's resting on the bearing area here and over here, and it's just put a block and there as a stop, and I will put these on for a little bit more control on the shaft. I'm not quite sure what material it is, so I'm using a stainless steel rod for it, 1.4337. It's a stainless steel rod that's also used for tool steels, and my experience with shafts is sometimes they're dirty, or if you get a little bit problem with porosity, and the stainless steel rods are much better with coping with that than the normal steel rods. So that's what I'm gonna use. Put a tiny little bead on there, watch the indicator, and yeah, see if it works. One other thing, make sure you clamp the ground on the shaft itself and not on the table, because the current will flow through the V-blocks and it will probably spark a little bit on the bearing surface or on the V-blocks. That's no good. So put it on the shaft and that will be fine. Interesting to see the indicator move. Make sure I stay off the edge of the bearing surface, but I can always put it on the lathe and turn it down. Slowly moving, rotate it a little bit. Have to let it cool a little bit more in between, otherwise the welding doesn't affect it as much as it needs to be. Alright, that's a lot better. 0.16 millimeters left. And what I did notice that the lowest or the highest point on rotation changed a little bit. It was over here, but now it's over here. So let's mark that and then put some new welds on there, on that edge, and I think this will work. Always fun to see the needle move. Alright, let's see how it looks. Here was the lowest point, but as you can see now the lowest point is over here. That's almost on the opposite direction, and here it goes up again, but very little. That's good. The weld in here is quite thick, and I reckon if I turn it down, because the highest point is now where the welds are, if I turn it down it will release some tension, and that will go in the opposite direction, so it's not pulling but pushing a little bit more, and I think that it will turn out straight after that, or I will just have to put a tiny little weld back on there. But first, now I want to turn it down and then check it again. So normally I would put some cutting oil on there, but I may have to weld it again, and then I don't want any oil on there. So I think my insert won't survive this, but I will turn it down anyway. So I got it back on the support where the bearing is mounted, because the problem is the center, and the live center is not in the center, so that's not a good point to measure. Put it on the bearing side over here and put it in a collet over here. I trust this collet to be good enough. So it's a whole lot better than it was in the beginning, but this, after welding, this was the highest point, and now it's back to the lowest point again, because I turned the weld down and the weld was pulling it up, and now the weld is gone and it releases it a little bit back down. So there did move a little bit inside the shaft itself, but that just means I need to put some extra welds on it again, turn it down again, maybe put some more, and then continue until it is straight. Alright, that cleaned up, and now we'll check the runout. If I'm happy with that, then I will recut the center, so I will be able to use that also. So I'm not quite sure how much tension there is in the shaft, and maybe the motor will warm up quite a bit or something like that, then it will move a little bit under the tension. So I will just temper it, and then I'm sure that there's no tension left inside the steel. I will temper it till let's say straw yellow. I think that's good enough, and just leave it on there. Just leave it, let it cool down by itself, and then check it with the indicator again. So while the shaft is cooling down, I thought let's use the opportunity to explain a little bit about welding and pushing, pulling material around, how you can use that to straighten a shaft. And if you're a welder, you probably know this, but if you're not or not familiar with it, then it can be very useful or stressful. If you're trying to weld something straight, it will probably bend a little bit. So first question, what will happen if you heat up material? Then it will expand, and if it cools down again, it shrinks again. The other question is, you probably know it's not a question, but if you're forging, so you heat up material red hot, you know with the hammer it's quite easy to move. It becomes like clay. So there's the yield strength, the elastic range of the material. If you go beyond that, it will deform, but that range will drop when it's red hot. So what happens if you put a tiny bit of weld on there? Then that material will heat up, the yield strength, the elastic range will go down. If it's only a small part of the shaft, then the rest of the shaft has enough body that it will stay in shape. That weld will expand because it heats up, that material heats up, and then there's no way to expand except outward. The yield strength is low, so it's easy to move outward, and then if it shrinks again, then it will pull the material in the direction with the weld. So with that in mind, if you know that, then you know how to use it, because yeah, you know it needs only, or it helps also if you're only welding a very small part. Put a tag on there or put a small bead on there, but don't cover the whole shaft, because then it will just move all around. And that's why it's also important to cool it in between, because if the shaft is all heated up at the same temperature, then there's no effect in bending or straightening. So yeah, maybe you knew this or maybe you didn't, and then hope you guys learned something today. Let's continue with the shaft. Let's see how it looks on lathe with the runout, and yeah, I hope that it will be somewhere in the range that I'm happy. So the shaft is back again at around 0.04 hundredths of a millimeter. I'm happy with that. I can't get it any better than this, because the whole shaft now has just a tiny bit of offset, because I was not welding it at exact the same position where it was bent. That means that the whole shaft is bent a little bit up and then bent a little bit straight again. So this one is not on an angle, but it's straight, but it's moving a little bit in a round circular motion. That's the offset that you see now. But this is good enough, because this is mostly for balancing. I will put on the pulley and turn that down on the shaft itself, so that won't have any run out. And just to check the rotor, that one has very little run out. So that's the most important one, that this one is not moving up and down, but that looks good. Don't think that this was really easy or fast. Maybe the video shows a little bit different, but it took me quite some time to do this because every time I welded it and turned it down, the tension released again, it dropped again, had to re-weld it, turn it down again, temper it in between, and go back and forward quite some times. I think I have the good equipment, I have the knowledge to do this, but I'm lacking the experience of someone who does this every day, who knows exactly how much weld to put on there to move it and how much it will release again when you turn it down. I don't have that experience, so it took me a little bit longer, but there was no problem because I can't really hurt it. It just takes a little bit longer. But just continue welding, turn it down, welding, turn it down, see where it moves and continue until it is good enough that I'm happy with it. So far so good, and let's continue this repair job.